A whisper came back from the James Webb Space Telescope, a hint, a subtle anomaly in the data suggesting our cosmos might be stranger, more intricate than the models we've built since Einstein. Breathe in, let's look at this together, gently. First, let's frame the central claim clearly. Webb is seeing galaxies so early in cosmic history, just a few 100 million years after the Big Bang, that they appear too bright, too massive, and too structured for their age. According to our standard model of cosmology, the Lambda CDM model, galaxies should grow slowly, accumulating mass over billions of years. These early galaxies seem to have skipped that awkward teenage phase, appearing almost fully formed. If this observation holds true, our standard timeline of cosmic evolution bends. It doesn't break, but it requires a new understanding. To be clear, Einstein's theory of general relativity, his description of gravity as the curvature of space-time, still rules the cosmos on the grandest scales. It's the bedrock of modern physics, but the simple recipe we use to describe the universe's evolution, a mix of ordinary matter, mysterious dark matter and accelerating dark energy, all expanding from a smooth, uniform beginning, may need some new seasoning. We're talking about extensions to the model, not a complete erasure of everything we thought we knew. Let's walk through the evidence piece by piece. Example 1, the impossible early galaxies. At a redshift of 10 and beyond, which means we're seeing light from when the universe was less than 500 million years old, Webb has found systems already rich in mature stars. These aren't just wisps of gas, they are organized, massive structures. This raises profound questions. Did the first stars form much faster and more efficiently than our models predict? Or is our method for calculating their mass and brightness off? Astronomers measure a galaxy's mass by analyzing its light, fitting it to models. Perhaps these early stars were unusually bright, top-heavy, with massive, short-lived stars that make the galaxy seem heavier than it is. Or perhaps, just perhaps, is some new physics quietly at work, accelerating the growth of structure in the infant universe. Example 2. The idea of cosmic textures. This is a more speculative but fascinating possibility. Some theories suggest that as the very early universe cooled, it went through phase transitions, like water freezing into ice. If the universe is part of a larger multiverse, a collision with another bubble of space, with its own laws of physics, could have left behind subtle imprints, defects or textures in the fabric of spacetime. These would appear as faint, large-scale patterns in the distribution of galaxies or in the cosmic microwave background. Finding such a pattern is not proof of another universe, but it is a breadcrumb, a tantalizing clue that our cosmic neighborhood might be more complex than we imagine. Example 3. Gravitational lensing oddities. Einstein predicted that massive objects like galaxy clusters would bend spacetime, acting like a cosmic magnifying glass. This effect, called gravitational lensing, allows Webb to see even more distant objects. But some of Webb's observations show light being bent a touch more, or a touch less, than our models of the cluster's mass would predict. These are tiny, painstaking measurements, mismatches that add up across Webb's incredibly deep fields. They could point to flaws in our maps of dark matter, or they could hint at a modification to gravity itself over vast distances. So, what would another universe even mean in this context? It's a concept that strains the limits of language and science. It doesn't necessarily mean a portal to a parallel world. It could mean neighboring regions of a greater cosmos where the fundamental constants of nature, like the strength of gravity or the mass of an electron, are slightly different. Our universe would be just one bubble in a vast cosmic foam, each with its own unique properties. Or, it could mean domains stitched together by those phase changes in the early universe, creating vast walls or textures that separate regions with different physical states. These are profound, beautiful ideas, hypotheses that must be carefully and rigorously tested, never rushed into sensational headlines. The scientific process is slow and deliberate for a reason, and that brings us to the crucial caveats. Scientists are, by nature and training, extremely cautious. They know that extraordinary claims require extraordinary evidence. Mundane explanations must be ruled out first. Things like instrument calibrations, the obscuring effects of cosmic dust, and a phenomenon called selection bias, where we might be accidentally looking only at the brightest, most unusual objects, can all mimic a revolutionary discovery. That is why teams around the world re-observe the same targets, refit the data with different models, and recheck every line of math. This is the heart of good science. Meanwhile, even with these caveats, the wonder is real and undeniable. Webb's magnificent golden mirror, a honeycomb of cosmic perfection, gathers ancient light that has traveled for over 13 billion years. And with that light, we get to compare the real observed universe to the elegant curves of Einstein's theories, looking for the small, subtle places where they might part ways. That is a profound privilege. In Webb's deep fields, every pixel holds a universe of information. The faint, distorted arcs of lensed galaxies and the tiny red smudges of the first stellar cities trace a story from the infant universe. A story we are only now, with this new eye on the cosmos, beginning to learn how to read. Each image is a page from a book written in a language of light and gravity. If confirmed, some of these hints could point to revolutionary new physics, perhaps new particles that influence the early universe, or interactions we've never imagined. Or, just as likely, they may fade away as our calibrations improve and our models become more sophisticated. Both outcomes are a victory for science. Both outcomes teach us something valuable about our place in the cosmos. A little perspective helps. Cosmology moves on patient geological timescales. Theories are built, tested and updated over decades, not days. The sky above you tonight looks the same as it did 1,000 years ago, and the stars remain calm and predictable in their courses. The frontiers of science are exciting, but they don't change the peace of the night sky. So let's try a small exercise. Breathe in, the quiet thrill of possibility. Breathe out, the need for absolute certainty. Just for a moment, hold the question lightly in your mind, like a delicate jewel. Appreciate its beauty without needing to possess its final answer. If a different universe did once touch ours, its mark would not be a cataclysm. It would be a whisper, a gentle signature in the patterns of light in our images, a puzzle for scientists to solve, not a danger in our daily lives. The cosmos is vast enough to contain mysteries without threatening our existence. So, what does all of this mean for you, right here tonight? It means you live in a universe that is still revealing itself. It means you don't need to have every answer to feel a sense of peace. The sky above you is steady, a constant and reassuring presence. In this quiet space, even the grandest ideas like new physics can become part of a cosmic lullaby. A gentle rhythm of discovery made of distorted arcs of light, patient sky surveys, and the quiet elegance of mathematics. It's a story of human curiosity reaching out across the darkness. Let your thoughts drift across the expanse of deep time, vast, gentle, and completely unhurried. Feel the scale of it, not as something overwhelming, but as a quiet, stable backdrop to your own moment in time. So rest now. Whether Einstein's model of the cosmos stands alone for another century, or whether it soon welcomes new companions to explain these fresh mysteries, the cosmos keeps its steady time, and we drift safely within its embrace. The search for answers will continue tomorrow. Tonight, there is only the quiet and the stars.